Okay, let's kick things off with a question that you've probably thought about in real life. If you're going to paint a room or maybe figure out just how much water a tank can actually hold, what do you need to measure? Is it the surface area or is it the volume? Getting this right is the absolute key to solving a huge chunk of your math problems. So, let's dive right into it. We're talking about mensuration, which is really just a fancy word for the mathematics of measuring things. It's the part of geometry that helps us make sense of all the shapes around us. From the Amazon box that shows up at your door to the water tank on top of your building. So to get back to our big opening question, we first have to really get the difference between measuring the outside of an object versus measuring the space inside it. Here's the simple rule of thumb. You use surface area whenever you're covering something. Just think about the paint you need for a wall, or the amount of canvas to stitch a tent together, or even the wrapping paper for a gift. It's all about that outer layer. Now volume, that's all about capacity. How much water can a tank hold? How much gas can you squeeze into a cylinder? That's all volume. Simple, right? Okay, so let's zoom in on that outside story first. Surface area is literally all about the parts of a 3D object that you could physically reach out and touch or cover up. So, when we talk about covering the entire object, top to bottom, all sides, we call that the total surface area, or TSA for short. Imagine you're wrapping a birthday present. You've got to cover the top, the bottom, and all four sides, right? That complete coverage, well, that's the total surface area. And check this out. This is such a great way to picture what's happening. See how that 3D box just unfolds into a flat shape? We call that a net. The total surface area is just the combined area of all those separate flat pieces. It makes the whole idea so much easier to get your head around. But what if you don't need to cover the whole thing? That's where curved surface area, or CSA, comes into play. For a shape like a can or a cylinder, the CSA is just the area of that curved middle part, without the flat circle on the top or the bottom. And this visual just explains it perfectly. Imagine peeling the label off a can of soup. When you lay that label out flat, what do you have? It's a rectangle. And this is the secret to the formula. The length of that rectangle is just the distance around the circle it was wrapped around, which is 2 pi r. And the width? Well, that's just the height of the can, h. So the area of that label, the curved surface area, is simply length times width, or 2 pi r times h. Pretty cool, huh? All right, we've covered the outside. Let's move from the skin to what's inside. Now we're talking about volume, which is all about how much stuff an object can hold. Simply put, volume is just the amount of 3D space an object takes up. In other words, its capacity. Thinking back to our water tank example, the volume tells us the absolute maximum amount of water you can pour into it before it overflows. And this animation makes the difference crystal clear. See? Volume isn't about the outer shell at all. It's about the entire space being filled on the inside. It's the substance, the contents, the total capacity of that object.
Okay, so we get the concepts, but how do we actually calculate all of this? Well, this next slide is your essential toolkit. It's everything you need.
And here it is, your master guide to mensuration. We've got all the key players, the cuboid, cube, cylinder, you name it. And for each one, this table gives you the exact formula for curved surface area, total surface area, and volume. Don't let the letters scare you. L, B, H, and R just stand for length, breadth, height, and radius. I would seriously recommend pausing here, take a screenshot, maybe even print it out. This is the foundation for solving pretty much any problem they can throw at you. Okay, theory is great, but let's put these formulas to the test with a real exam-style problem. This is where you see how everything really connects. So here's our challenge. We need to figure out how much canvas is required for a conical tent. We're told the radius of the base is 7 meters, and the straight-up height is 10 meters. So first question to you is, are we looking for surface area or volume? And if it's area, is it the total or just the curved part? Now, to find the area of the canvas, the formula for a cone needs something called the slant height. That's the length of the diagonal side, what we call L. We weren't given that directly, but no worries, we can find it. If you look closely, the radius, the vertical height, and the slant height form a perfect right-angled triangle. So we just use the good old Pythagorean theorem to find L, which works out to about 12.2 meters. And now that we have all the pieces, we're golden. We grab our formula for the curved surface area of a cone, pi times r times L. We plug in our numbers, do the math, and bam! The total canvas we need is 268.4 square meters. We just went from a real-world problem to a solid numerical answer. And here it is, the crucial point that answers our earlier question. Think about it.
For a tent, you only need canvas for the sides, right? The floor is just the ground. That's exactly why we use the curved surface area formula and not the total surface area. Spotting these little real-world details is the key to choosing the right formula in your exam.
So to wrap this all up, let's lock in a few key exam tips. Number 1, always read the question super carefully to decide if you're dealing with area or volume. 2, identify the shape correctly. 3, make that critical call. Do I need CSA or TSA? And finally, please double check your units. Such a simple mistake can cost you a lot of marks.
And if you want to really focus your practice time, these are the topics that pop up in exams again and again. Make sure you can explain the difference between CSA and TSA in your sleep and really master the formulas for cylinders, cones, spheres, and hemispheres. These are the heavy hitters for sure.
So let's bring it all home. Mensuration isn't just about a bunch of abstract formulas in a textbook. It's a really powerful tool that helps us measure the things we see every day, to understand how much they can hold, and to figure out exactly what we need to build or cover them. It's the math that connects directly to the world you actually live in,